Good to check these things. Hi, everyone. Welcome to Cloud Robotics Working Group. Today, we have some more guest speakers. Thank you for coming, Victor and Sergi. I don't have anything else to say, so I'll pass to you for introductions and tell us about INSAION.
Yeah, thanks a lot for making us a spot over here. I prepared a little small presentation that I'm going to share right now. Can you see the screen?
Yeah.
Perfect. Well, basically, INSAION, it's a company with the full objective to keep the robots running and healthy. This is something that we phase in the past, Victor and I. And basically, we came up with the name of INSAION for insight and action, like gather the information from the robotics fleet and try to reduce the mean time to resolution of an issue. So myself and Victor, we worked together for several years developing autonomous robots, and basically we come more for the aerial space. And there, what we face is basically sometimes that the cycles were a bit slow when you need to go into airfield and start testing with drones and so on. And we saw that it was like incredibly valuable to have like this field data, but we didn't have like let's say many proper ways to actually record it, or we were droning in a lot of data. And then is when we came up with making this solution. And basically, yeah, you are at home or developing, and then a robot just fail, and then how long until you know why? And here, what we saw basically that we were having like quite slow cycles in general, like the quite reactive at the beginning. Once you start scaling your fleet, then you start seeing that you need to put monitoring tools into place, to get a bit of proactiveness, but still the issue resolution sometimes was going like too deep. Like we had like hardware into place, environment, reflections, and well, things that we know like in other industries that are not working in autonomy, that doesn't happen that much. And then we wanted to come up with some sort of solution. The cost that we are seeing there is like basically when the robot fails, we see also a broken workflow when normally you have an operator or someone on site, that gives reliability, but the information that it gets is quite big. And we see like normally tries to resolve the issue on the field, and if this escalates, then it goes like to customer support in reliability engineer, or someone who can access remotely and see what is going on. And most of it was like getting the right data and analyzing, and this we see like it increases the mean time to resolution. Also, it's quite costly for companies, especially in the logistics sector. How we see this challenge is that mostly when you develop and you are in a pre-prod environment, we see there like there are already like quite good stack there where you can have physically you can access to the robot. You have like deeper visualization tools, and you are in your playground where you can actually develop there. But the reality when you start deploying on multiple sites, and if you also deploy multiple vendors of robots, then this how to get this data and compare it, it makes much of a pain. Like comparing, having multiple software versions deployed, different hardware, having done maintenance on the robot, And there we see like it requires a lot of extra things, like having not only monitoring and alarm, but also like managing the incident, having a smart data capture, and of course analyze also the data to get more insights and try to reduce this mean time to resolution as much as possible. Mostly what we see, like we normally start non-reactive SSH, and then we start like putting some measures in place, and we see a lot of tools already more towards focus on the IT observability, which give you a really good ground to start with, but there are like some nuances that also we notice when setting up Grafana and so on, that they were more focused on IT, and then the moment that we were seeing that we need more info, then it was like extra work on company side, to actually make those development and try to get that data and fetch it to Grafana. And we are talking about failures that are tied to real world physics. Each robot, even though if it's the main manufacturer, they have still like different versioning, different hardware that is changed, that some models that are older, and still you want to keep all of them running, compare them, and have some more verbosity on what is happening. So instead of getting just like, okay, something failed, great, I want to know more, like, okay, it fails, like as an example, because LiDAR had a maintenance 3 days ago. There is a way we can actually track this and put this information into place, so we can have like some more, instead of making guesses, having like some more actual information that help us. One thing also, and this as well open to discussion, you can also chip in your thoughts in here. When talking with a lot of companies, there is like some companies that they believe like this should be responsible of the fleet manager, and yes, it's true, like there are already like some error diagnostics coming from the robot, and you fetch it into your fleet manager that helps you to recover from issues that The problem, I think, like here is when you don't know it, right? And there you need to have like way more context, So I like to kind of separate like the fleet manager more for execution wise, and yes, it will have like some part of let's say basic monitoring to keep the operation going. But when we come into observability in large scale, we need to be able to provide some comparison between the groups of fleets that are deployed and find a quicker way to do a root cause analysis. So what we built is an observability platform for robotics, where we focus in knowing this that I explained in these 4 pillars. One is trying to unify all the robotics data, which is quite a lot of unstructured, as you know. For this, we support like natively ROS2 integration with any type of messages can be custom. And as well, what we do is like we retrieve metrics from the host, or let's say modus operandi or way of living is like we don't want to put APIs or SDKs. We believe like this should be like kind of plug and play, and get fast to the ground, grab your data, and then you are good to go. Also, it allows you to be vendor locking, so you don't spend months of developing an integration and then you actually need to change your solution. Then a way of monitoring all your data, like having the possibility to visit data from the past, setting up some alerts fleet-wide, and manage the incidents that are happening. There we see like as well as grabbing the information from the technician on the field, for example, like we can add it as a context for later on do a combined analysis. We take the data that is related to an incident and basically we perform some classical statistical analysis. We get the mean, standard deviation, we calculate correlations between the data, and then we feed it to LLMs in order to interface in an easier way with the user. So in the end, we want to simplify that process. We don't want to be deeper knowing what is happening and checking a lot of data and graphs and then guess what is happening, but rather have the analysis engine over there. And better way to, if you have of course an interactive visualization where it can tell you zones that might be of interest for you to look up and help you to diagnose the issue fast. A bit the architecture that we have is putting in a robotic fleet. We normally deploy an agent that is in a Debian package, and then from there we grab all the ROS2 topics, standard or custom, and then we grab some host metrics such as network that it's depends on your application. It's quite a pain. We grab as well as the GPU information, CUDA version that you are running, driver, and so on. That it also helps you, if you might have some issues over there. And then we grab as well the logs. So we see normally in the industry to set up a rolling buffer, no? So here is where I think the data capture, smart data capture comes into place, where basically an incident happened and I'm monitoring some data because I don't want to be hammering the network. And then what we do is when an incident happens, we can grab the data from the rolling buffer and actually put it on the platform by itself. For this, what we do then is we send the data to our API gateway, and then from then on we have a front end where you can visualize, making dashboards, managing all the alarms and incidents and so on. We store this in a database for time series. And then we have a module for scheduling alarms and executing them, as well as the analysis engine that I was mentioning before.
One question here on the last. Yeah. The ingest is kind of where sometimes the difficulties come in. Your API gateway, these secure data ingestions, are those just HTTPS requests, or how do you ingest data?
Yeah, basically we have the authentication token. So we are using on the agent Telegraph, and then we are sending HTTPS, yes. And then we send in the header the JSON token for verification.
How do you deal with robots being offline, failed deliveries, lots of backlog? Like if the robot was offline for a few days and it comes online, one common request that we hear a lot is, I don't want you to start uploading the oldest data first. I want you to upload the newest data first, because that's what matters most to me. Can you say a little bit more about that whole retry logic and all of these things?
Yeah, basically right now what we support is a buffer. So we fill in a buffer, and then based on that, whenever we become online, we flash the data. Of course, if during that process the robot became completely power off, we lost that data right now. No. From there, what I see is of course, it's having a database in the robot by itself, no, and being storing the data over there. So then basically you can query as you want. But right now we are not really supporting.
Okay, thanks.
How we also envision this is to offer different deployment models. No, I mean we see to try to get customers getting to speed and try out with a cloud environment. All this has different 3 tiers, and then there is a free tier that you can actually test it out. And I think it's quite suitable, for small scale fleets and fast to adopt. But we come from the energy sector as well. And then, for example, there we know data security, it's really important, and then basically you don't have like access to the outside, so any data cannot just go outside. So we offer an enterprise plan as well, like where we see you deploy the solution self-hosted, and then you manage all your ownership of the data, privacy concern that you might have, and so on. So these like to actually support like the most restrictive sectors such as logistics and energy. And yes, so basically now we can show you a bit of the demo that Victor prepared, where basically what you are gonna see, it's how we are visualizing the data and ingesting it, and how we can generate incident snapshots to understand more what is happening in an incident and how this reflects in the whole process. So from going to reactive and moving towards a more proactive way, like in reality, what we would like is getting even knowing when the errors are happening before they happen. That's the core objective, but we know like this is something that needs to come later, when not right now, of course. And yeah, that's basically it. So if you have any questions or additions.
Okay, I'm gonna share the screen. I hope you see it. Feel free to interrupt any moment. I want this to be pretty like dynamic and interactive. So feel free to stop at any moment and comment, okay? Okay, so this is the homepage of the web application. It just shows a basic summary of your workspace. Here we created a mock-up organization with simulated devices, 10 devices to be specific. And I will show you a bit the whole workflow from the onboarding of devices and how you configure them to the monitoring and the alarming and analysis. So first of all, here is the view of the devices, all the devices that you have in your workspace. How you onboard them, Sergi already explained a little bit, but it's pretty easy. It's a one-liner command that you execute on your robot, and the agent gets installed. And then we have two security methods to register the device. It can be an enrollment key, which is more like a secret token that is more long-lasting, and you can use it multiple times for multiple robots and so on. And one which is more like temporal, so you can just use it once for one device, and that's it, and it expires after a few minutes, just for the sake of testing and so on. This is more manual, and you need to input it, and you cannot automate it. Once we have the agent running, it will appear already here if the token is correct. And we can go inside to see the basic information we have. So you can check and change the name, again, the type, and so on, basic information. And then you will see in this section called sources, all the data sources that we are able to discover from the robot, okay? Some sources are already taken from our agent by default, let's say all the host metrics that we call it. And this is done automatically by the agent. So you don't need to configure anything or worry about it. We will just collect CPU, GPU, memory, network, and so on. Of course, if you don't have a GPU, we will not do it, but the agent adapts. So all this is done automatically. And then it also shows the ROS2 topics that you may have. Yeah, and this is auto-discovered. Again, it works with any kind of message. We support also custom messages without problems. And in here, the key is to select or check the ones that you are interested in monitoring. Yeah. Once you have this selected, you may create a template. So basically, a template is you store this configuration which allows you to then apply it to multiple devices. This translates to a way faster onboarding process and to scale the whole of operation on onboarding and monitoring the robots to simply one click or even automatic, because you could select a template to be the default one, and then by default, when a device is registered, it will automatically apply the template. So you don't need to worry about anything. You simply get the data monitored automatically. We also have the part of the metadata, which right now is a bit raw, but the whole idea is basically to also keep track of the non-standard metrics and to try to group the robots in hardware versions and software versions and different components, that it's not just about the metrics and that's it. And this would serve as a comparison to compare different groups of robots or groups of production lines that you did. For example, you could compare a ROS distro Jazzy that is running on 5 robots and ROS distro Humble that is running on another 5 or 6 robots, and see if there are differences, in performance, in terms of efficiency, of optimizations, and so on. And this can be extrapolated to anything. You can do the same comparison with the camera, for example, or different LiDAR firmware or model. And we believe that here you could find really a lot of information hidden under the hood of the root cause of problems and so on.
So is the software version attached to the robot? So if you wanted to look at historical data and see if a previous software version on the same robot performed differently, is that possible?
Yes.
Okay.
So we keep track of the history changes here also,
Nice, thank you.
So you could understand that at this point in time, this got changed to 2. So then you understand that all the data previous to this time, it's from version 1. This is the logic behind it. Then we have also an interesting feature. It's not yet deployed, but the whole idea behind is that we know that you cannot monitor everything because it would congest the whole network. So we also advise to just monitor what you really need and the main the key sources that will make you understand if something goes wrong. And from there, you could create a trigger that does the rolling buffer and then uploads it to the web application. And then in this rolling buffer, you could have a more heavy scope or snapshot of your whole system with more heavy data, like point clouds or super high frequency topics and so on, to be better understand the issue and have a full overview.
To confirm, it's constantly monitoring some topics and it's able to capture snapshots of more topics when an incident occurs.
Correct. This is coming. The snapshot thing, it's on the way, but this is constantly monitoring what you select on top. Yes. How it works, I could go a bit deeper.
Do you record these topics like every message, or do you do any sort of throttling there?
So far, it's every message, but we already got some feedback that would be interesting to also set a specific frequency to downsample also.
Yeah, because
in
otherwise,
some specific topics.
The problem usually is that robots produce way too much data, and you cannot possibly upload all of it. That would cost you a fortune if you do that over LTE. So, I mean, obviously you can select topics, but in a lot of cases, I mean, imagine you selected an IMU, right? Like that's sort of the typical example. You may get like 200 hertz messages there. That will fill up your storage and bandwidth very, very quickly.
Exactly. So we see that the downsampling also, we wanted to offer it from here. And so the users could simply downsample it without the need of creating an extra topic on top, downsampled, and so on. So how it works under the hood, basically the agent has this configuration, and we fill out the buffer and flash it every X amount of time. Okay, to the server. So it's near real time what you are getting on the application for visualization. Yes. Then also to organize a bit better the whole devices and things from the organization perspective, we created sites. You could call it sites or deployments or other things, but at the end is a way to distribute your deployments in different locations or by clients. Or we see it's also pretty useful to separate this, so you can, for example, have some dashboards just targeted for some specific site or some specific deployment to better scope the whole system. So the monitoring. This is a monitoring. Here you can create multiple dashboards at your convenience. Normally, we have a fleet-wide dashboard that it displays the full overview of the whole system with this structure. We think it's pretty convenient to see easily a big amount of devices and see quickly if there is some problem. Here it's just displaying, for example, if they're online, and here it's displaying the CPU. So you could quickly check if some devices may need some attention to then drill down or go down into this level. Then you can create some dashboards more like you see site-wide. So this is how automatic. The second you would add a new device or remove a device from a site, it will get automatically updated here. So there is no extra job you have to do. And as you can see, we can support different kinds of visualizations. And then you come to these, which are more targeted to the device itself, to drill down more specifically to see the console or see more specific more historic in a specific device. These ones are auto-generated, and then with a basic metrics, and then of course the users could add more panels. But at least you get this just by adding the device, it already gets generated. Then what else? We have the time range, so you could do the classics, visit the history with the calendar or the previous 6 hours or 3 hours. Then you could control also the refresh rate of your dashboard. And I could show you what other visualization types we have. Apart from the ones you already seen, we also have the image. We also have a 3D scene and a geographical map to display data. Of course, the image is not live stream, so we show a snapshot of the latest refresh. It's just to understand, because this application is thought to be for fleets and to grow your robotics devices. So we need to think that there is no human that can look at, I don't know, 20 streams at the same time, not even at 3 or 4 at the same time. So showing just a small snapshot, it already tells you from the fleet perspective what's going on or if something is wrong, also to understand the context.
How often do you take a snapshot on the robot and upload it?
It's configurable. You could configure it.
Cool.
You could do every second, every 2 seconds.
Well, every second is already a lot of data, right? Images get big.
Mm-hmm. Yes, of course, that depends on what kind of data you are monitoring. Once you have the monitoring dashboards, we also could create some alarms on top. Here you can see the list of alarm rules. So for example, we have 2 kinds of alarms so far. The classic simple targeted for an individual metric, which basically you define a metric and it gets applied to all the robots with a single rule. or you could filter by the metadata, and then you also filter the devices. Then you set the source and the threshold, pretty classic, and it gets triggered when this happens. You can set the frequency of evaluation, the time window, and so on. Then we have also another type of alarm, which we call it group comparison, which takes advantage of the metadata that I was explaining at the beginning. So you take a group A, which, for example, software version 2, and a group B with software version 1, and you can say to trigger an alarm if for example, the CPU of group A is higher 20% than the CPU of group B. Yeah, so like this, you could start to see if you maybe introduced a regression or some problems in your development. The same applies to hardware components and other metadata that you may add. Then these alarms, when they get triggered, they generate an incident. So this is the list of the incidents. As you can see, we can filter by status, we can filter by name, or filter by time even also. Just give me the latest one. So for example, we could see the incidents of the high CPU, and then we open it in the debugger. And what will happen in the background is that we will send all the information to the analyzer. We will get the statistical analysis, trying to understand from the trigger, which is the high CPU, we know it, try to correlate this with other data that is in the system and see the relation if something matches, to try to understand more holistically what happened from a system perspective, if there are some other relations. And then we pass it to the LLM to get more a human explanation, yeah, not just numbers and plots. So then here you can see that the CPU, high CPU, got correlated with the linear velocity, which dropped to 0 at this time. And also we got an increase in the motor temperature, for example. It's just an example to showcase. Notice that the whole dashboard was auto-generated, so you don't need to do anything. The whole system decides what metrics to plot, where to put them, and how to distribute them among the dashboard. The only thing that is manual here so far is the annotations, which is a thing we are working on also to annotate, which is these human labels. But the rest is all automated. We also have the topic explorer, which basically is the manual part. You could split a pane like a classic tool you would do, yeah, and drag and drop classically if you want to do this manually, this process, or you want to see something else. Then we also have the last part, which is the log management part. Right now here, what you can do is to upload manually MCAP files, okay? And at the same way, you can label them, you can add a description, and you can visualize them also in the same tool that I just showed. This in the future, it will be mixed together with the rolling buffer. So the actual MCAP rolling buffers will end up here, and it will close the cycle. Right now, it's just manual upload of files. And then aside from all these, we have the classic applications, like you could change organization, you could invite users. Yeah, we have role-based access, so you can also choose the role of the users to give access to, for example, generating tokens or inviting other users or seeing a specific dashboard also. Here you can manage the templates also from the devices, and the enrollment keys, which is like the secret tokens that I was explaining. And this is a bit the whole overview of the web application. So if you have any questions, please, we'll be happy to discuss, or some discussions.
Yeah, thank you for the demo. My question is quick, so I'll just do it right away. Have your customers expressed any interest in live streaming of video, or is that, I guess, if you can tell me a little bit more about your deployments and in what kind of capacity people use it and how big they are and so forth, that might help me understand too.
Yeah, so far, as I was saying, it's not really targeted how we see it for a specific device only and live streaming. You could simply do the rolling buffer and then play back the video streaming.
Yeah, that works unless you have to intervene, right? So a lot of times the operational team of the robotics company or the operators, wherever they are, get called on by, for instance, your alerts, right? You get a real-time alert saying like this robot is stuck. And then sometimes the robot does need help from a person. And for that to decide, it's often very useful to be able to see, what's going on, especially if you then have to do minor teleoperation or teleassist or something like that. But it sounds like you haven't come across that in your deployments yet?
No, not so far. Not so far.
What are these deployments like? Is it indeed warehouses?
So far, we are targeting, yes, warehousing and the logistics sector.
Okay, so it sounds like you are in a fairly early stage, because you say targeting. You don't have a large scale deployment yet.
We have pilots.
Yeah, we are at piloting stage. Yes.
Mm-hmm. Cool.
I had a question about the alerts. You said you've got alerts that can be triggered in the cloud that generate an incident, and there's also alerts that go on the robot that trigger a heavier rolling buffer. I know you said that that's work in progress. Are they the same alarm? So the alarms are synced from the cloud to the robot and monitor locally?
Yeah, so the idea of this is basically, imagine like from this alert, I want to trigger the rolling buffer. So basically will be simply in the configuration page, I will have here the option to choose when triggered, also trigger the rolling buffer, no, and choose which sources. And this in the background, when this will happen, it will collect the buffer from the robot and upload it to the platform when possible. At least store it. And then at the uploading phase, we need to see, because that's the challenge. No? We need to see if the time is appropriate, or it's better to have a button and just sync it, let the user sync whenever it's convenient, and so on.
Great, thank you. I see we have a hand in the queue. Session, please go ahead.
Yeah, hi, thanks. Thanks for the presentation. I would like to ask regarding the observability of the data. Are you also considering like getting the logs or some kind of traces or span from the program itself for better diagnose the issue or some crash, something like that?
Thanks. I didn't get you. I think you said the log from the processors.
Yeah, I mean, for example, in terms of observability, it's like you can get the logs from the application, but there are sometimes some things that we can add in the application itself. For example, there is rows to trace, where basically you can get the data from the program itself, like, for example, to analyze the application in that direction.
Yes. Of course, we are always expanding the amount of sources we offer. This is a continuous job. We are also looking into looking at the whole system processes of the computer, or also allow to filter just by the raw processes, but also show the processes. also try to show somehow the whole nodes in general, the nodes of ROS, somehow trying to show the status of those nodes, which we believe also it gives a lot of information. So we are always welcome to all this feedback, and it's an iterative process. We always keep adding new stuff.
Yeah, that's interesting. Thanks.
Any other questions before I go ahead?
Yeah, maybe I have one. Thank you for the presentation. Very nice, very impressive. I wanted to go a bit more into the incident management. You were saying when an alarm generates an incident, then you can drill down. The correlation will be calculated automatically between the topics that are relevant, or I imagine you take a window of around the alarm,
Yes,
or from the alarm
exactly.
after, I imagine,
Yes.
because the alarm needs to be triggered. Well, probably you're measuring something before to trigger the alarm. And then you were saying the correlation between topics is done automatically. Can you tell me a bit more about that? Because I imagine this happens before you actually engage the LLM, because the LLM won't be dealing with the entire
of course.
Yeah.
So basically here, to explain a bit more, we indeed take a bit before. So we have a time window. That's how we know when to crop the data. And then all this, we fed it to the analyzer, which basically computes the statistics of all the topics of that device. Okay, all the topics that you are monitoring, that you have selected in here, we compute the statistics and try to find the correlations among them and other statistics, statistical analysis among all of them. And from all of these is the result that we get. Then after all this, of course, we pass it to the LLM, and then the LLM also does the whole summary and decides what to plot.
Understood. And the other thing, to close the picture, because you were mentioning a buffer on the robot that then is flushed whenever you're sending over basically all the topics, for also there for a time window, I guess.
So yeah, how it works. We collect the data, we subscribe to the topics. Okay, for the topics part, we just subscribe and store it in the buffer, and then the buffer is flushed every X amount of time to the server.
Okay, so I imagine, so just to understand, then there's the buffer. I guess it's configurable how large this buffer is. So for what window of time you're collecting the topics your agent is subscribed to. So it accumulates them, it flashes them, sends them to the cloud, and then on the cloud is where the alarm is generated. Or this is the other thing that
everything happens on the server.
Yeah. Okay, because this is, we saw, I don't know if you saw the previous videos about this set of guests talking about observability, but we also had some guests. We also had some guests that were doing this, right? That they were doing, I don't remember exactly which ones they were, some apologies, but they were actually declaring the alarms and then deploying the alarm logic, the logic that detects the alarm on the robot itself, right?
I think
so
this
Right. It was Higgs, exactly. Thank you very
much. From our side, we think, since we come from the aerial robotics area, we need to keep things really efficient because the computers are really small and we don't have a lot of bandwidth. So we always try to keep everything lightweight. So we created the agent, which is extremely lightweight, and it does the minimal. It's just collecting and forwarding. That's it.
And it makes a lot of sense, because I think for transmitting, we also discussed this last time with Christian also. Once you have a topic that repeats itself it's high frequency, but it's quite repetitive, compression can really help there. So if you compress, then you should save some bandwidth.
Yes.
That was my question. You have one other question from, or is it still the same hand?
Yes, Hi, thanks. I wanted to ask, sorry, I did not get in the talk. Maybe like, how exactly are you like subscribing to multiple topics or data from different robots? If you can share a little bit more on that.
Sure. So our agent, it's individual, yeah. So an agent is deployed to the robot itself, and then the agent detects if you have ROS, and then it spins up a node which is in charge of doing the whole process, yeah, discovery, collection of schemas, if there are custom messages and so on, and also subscribing the data and forwarding it to our collector and then sending it to the server. Yeah, so that's how we escalate to multiple robots, because we install an agent to each robot.
Okay, like for sending the data to server after it is being collected, like are you using like some TCP, or like which kind of protocol is good in this sending of data, like which is huge or like that?
We use HTTP.
Okay, okay, that's interesting. Thanks.
So I'll go ahead again. Yeah, you said you had a pilot program, I think you mentioned. Wondering what kind of feedback you've had from either the pilot program or from previous customer conversations you had while building the tool. What were your big takeaways?
Mm-hmm. You want to kick in, Sergi, maybe?
There are different things. I think like one of the things that we realize is that they want more. It's not enough only host metrics by itself and ROS2 data. We can see like they are asking more for operational intelligence layer as well. So this is quite interesting because they want to have like also a full view on how this is translated to business, right? Like the robot is operating, but if we have like doing like an inspection round and so on, how much area is being covered and so on, how much are the deploying rates, and this gives you the possibility to actually, when they have their customers, to actually show how they are performing their robots. This we see like quite an appetite. And then the other side, I think like more from the agent side, to get more data. Not only the host metrics and ROS2, but also like having like data from the Linux services that you might have and extra things. And this we see like it might differ, depends on the vertical, to be honest. Yeah, that's a bit of what I would say. I didn't came across with the, let's say, the challenge that Christian was talking, like to have like the real-time data, because normally you have the fleet manager that actually does that. So basically you can actually control it with the fleet manager and have the video stream over there. But yeah, I think it depends, no? I think like when you are looking into observability, you need to be like quite careful of what you are grasping, right? And any information can make the difference. Yeah, that's a bit what we got.
Nice, thank you. I think that's a good insight that you customers want to know how well the problem is being solved, not how well each robot is solving a problem. That's great. Thank you. That's all my questions. Anything from anyone else?
Something that made me think about something Christian said a while ago about the maturity of deployments. You are targeting already deployments that go from 10 to 100 robots. So the applications are quite advanced already, quite stable, I would say. And I was wondering whether it's just an idea, but maybe you already thought about it. I was wondering if it would make sense to have a sort of log also of the resolutions of the issues you had found, because you have this nice idea of the grouping of robots that have same configurations, whether it is hardware, whether it is software. So I imagine if an issue appears across different warehouses where something is similar there and it gets solved, maybe not solved, because solved means there's a bug and you found the bug and you solve it. But maybe you just have a workaround to get the robot down running for the next 24 hours at least. Are you collecting something like that? Are you thinking of doing something like that?
Yes.
Is it asked by the clients?
You nail it. Yes, they ask it a lot. Actually, like understanding just like, and this how we want to do it is with the incident snapshot. No, since we want to also get like an easier way to say, yes, this problem happened in the past, and here you can look at a snapshot that happened in the past, and this was the resolution. And our idea is to transmit this to the more, let's say, operators, no? Like sometimes they want to have like a quick action. So I'm in the field, the robot just stopped. There is something I can do. Ah, yes, this happened in the past. But let's fix it like this. We fix it like that, or at least try that, no? And this is something like we see, yes, we have the baseline, and now what? There is more and more features, no? Like more towards this to understand like how the incidents were resolved in the past and compare among them. Yes, definitely.
Very good. And this brings me to the other, because one thing is this is what I was talking about, maturity of the deployment, because then apart from having a larger fleet and more stable software, more stable platform, you will also have more layers of incident management. So you will have the local people, you will have the customer care, you will have the devs or the robotics engineers. And are the roles that you have there enough for representing also these things, the insights?
I mean, of course, right now, no. Like, but this is what you see, like Victor showed, no? Like we have a multi-tenant platform over here. So basically, what we are expecting here is to have a role-based access, have like a specific dashboard for every type, no? So we see like also operation managers, they are asking, or managers, they're asking this kind of features. Like I want to see like how it's performing, how we are resolving, how it's costing me this. It's costing me a lot of money to maintain this. Then we have another view, no? Like more like in the field, and all these kind of pieces, they need to put it in together because the data is there, you know. It's a matter of just like developing and keeping pushing forward.
Yeah, just to add up, we see it as a collaborative platform at some point, that you could distribute your teams in the same platform and they use it in different ways. So you could escalate the issues to higher teams or some other teams, and also even the executives, and at some point to see high-level reports, performance, throughput. The data is there at the end, and we see it a way to centralize it, and it's a matter of a nice way to collaborate in the same place.
Absolutely, indeed. Sorry.
Oh, I'm sorry. I thought you
No, go ahead. I'm done.
Who's your customer? Like, who do you sell to? Robotics companies, or do you sell to robotic integrators, or how? Like, who's your customer?
Yeah, robotics company at the moment. Yeah. Robotics company at the moment.
Companies at the moment. Okay.
Yes,
because because the business results matter to their customers, right?
Yes. Yes. And the incident resolution as well. So the thing is, as I mentioned in the presentation, there is a broken workflow. Yes. Between what is the engineering and the robotics providers, and then what is like the actual customer, right? And right now, this workflow works like quite reactive. You might have like customer support, system integrators in the middle, like making us a buffer. But the thing is, like, there is no a cross correlation over there, right? So how we are approaching this is like we're starting from the robotics perspective and then like scaling it up.
Okay, thank you.
I think we're just coming up to time now. So I wanted to thank you both for coming and talking to us. I think it was really interesting. I think the visualizations you've got are great. I'd have asked more about the 3D scene. No idea how that works. That would have been cool to ask about. But as it is, next session, we don't have, this is housekeeping for working group now. Nothing planned for next session at the moment. I'll announce what the session will be in the usual places, the Cloud Robotics Hub, ROS Discourse, Google Groups. We do have another observability customer coming up. That will be in a few sessions time because they're quite busy, but hopefully that will be interesting when we do see it. And I think that's it. So thanks everyone for coming. It was great to learn more, and see you next time.
Thank you.
Thank you.
Bye.
Bye.